Okay, it's time to start the meeting. Good afternoon, everyone. Welcome to the CAS meeting. And I'm Peng Liu as the co-chair on site, and Adrian is on the remote. Our secretary is Cheng Li, and our AD is J. Okay, um, and also good morning and good evening to the online participants. So it is the IETF note well, just to remind that when you participate in the IETF meeting, you are agreed to follow Mike. Where to? Okay. Okay, thank you. You are agreed to follow the IETF process and policies. And for about the patent IPR, please note that you should disclosure it at any time, not only before the adoption call or the last call. And okay, the personal information that you provided to ITM will be handled in the accordance with the privacy statement. So more about the information listed below in the PCP. And for the conduct guidelines, please remember that you should be respect and courtesy to your colleagues at all the time. And we have the impersonal discussions to diverse solutions for the global internet and meet the needs of diverse technical and operational environments. And individuals are prepared to contribute to the ongoing work of the group. So is my voice clear? Okay, thank you. So we are using the Meet Echo queuing control. So for the on-site participant, please also log in the Meet Echo. And the note is taken by Cheng Li, but we hope that everyone could help to make the information correctly. And the link was sent in the chat box. So for the in-person participants, make sure to sign into the session and use Meet Echo to join the mic queue. And you should keep audio and video off at all times. For the remote participant, just to open your audio and video when you speak, and please keep close it when you don't speak. Yeah. And here are our milestones and deliverables. Now we have adopted the problem statement, use case, gap analysis, and requirements document. And we just adopt the framework and the architecture document before the meeting. So we hope that everyone could contribute and review the document to promote it together. And here's the agenda for this meeting. We will have the presentations of use case and requirements and the framework. And we will have two presentations about the compute modeling and the metrics. And also has maybe use case for the mid-haul networks and also for the analysis of method for distributing the compute metric. Um, Meanwhile, we also have four presentations that just to flash the slides. Maybe those works may not be written in the charter now, but we encourage people to contribute more work and show the interests to the working group. So any comments on the agenda? Okay, let's start our presentation. Okay, first one. Go ahead, please.
Hello, guys. Thanks for for the chairs for introduction. So I will give you a quick update about the working group document, use cases and the requirements of CATS, representing the co-authors. Next slide, please. So after the meeting in Prague, we have made some modification and merge of the drafts. We have merged the use case from Alibaba Group, and also we have merged a requirement from contributors from DTE. Next slide, please. So about the use case about compute-aware AI large model inference, as I has already presented in Prague. So like this use case is more focused on highly interactive and real-time translation applications like ChatGPT. And also behind these applications, they usually use large language models. So training large language models usually needs like tens of thousands GPU costs, but most of the providers usually deploy their training inside data centers. So like AI training might not be within Casco, but on the other side, like distributed AI inference, which usually needs the compute instance for like interactive computing. They are distributedly deployed in different edge sites. So selecting different edge inference like instances and in real time is within CAS scope. So next slide, please. And about the requirements. So we have added, we have newly added a requirement merged from the as I said, from contributor from DTE on the matrix collection. So like you can see in the word in blue, like collecting matrix from all the service instances may incur like much overheads for the decision maker. So we add a requirement that should provide mechanism to aggregate the matrix. And the CAS components do not need to be aware of the how matrix are collected behind the aggregator, because we think that it's not within CAS scope and should be determined within the compute or edge service providers. Thank you. And the next slide, please. And another modification on the requirement is about and matrix definition and use of matrix. So you can see that in red, we have deleted the requirement according to some discussion from Prague, that the previous requirement is must include a default action for the interoperation of network nodes, which may or may not support the specific matrix. But according to this discussion in the last meeting, that people might not don't agree that the network nodes need to aware of the specific matrix. So we have deleted this requirement, and then we add a comment that for matrix that CAS components do not understand or support, CAS will ignore them. Next slide, please. And also, we have summarized some discussions recently on the mailing list. It's probably there was a thread about on the topic that whether SFC should be a proper use case in CAS. And also, I have listed the thread link. You can go to the details about the link. So I have summarized some key points. If I miss something or I misunderstand about something, please let me know. So first is about the definition of service in SFC and CATS. So I have referred to a definition from Joe, and also I see that people, most of the comments have consensus on this. So service in CATS, basically services here is referred to that they can be addressed by client applications, while service in SFC is mainly about operator-based services that could improve client applications. So here we see the difference. And about how to use them. And the differences are reflected here, that CAS is about sending traffic to a compute instance. And these compute instance will run client applications. And then we will get, the sender will get a response. While SFC is about sending traffic through instances. While these instances may run like operator service functions along a predefined path, that is service function path, and towards a destination. So sometimes that SFC may have a loop which that they will receive this response, but typically in the Euro case that SFC may not need a response. So I think these are the major differences. And also there are some similarities, like construction of SFC or SFP can be enhanced based on computing awareness, like a comment from Chen Li from Huawei. He said it can be named as computing aware SFC, but this is not currently not a use case in CAS working group. So out of the CAS working group scope. So next slide, please. So a quick summary and for the next steps on this draft. So should we update the terms of computing service of the two working group documents, the use case documents, and also the newly adopted framework document to clarify that CAS is more about the user traffic? I'm here to solicit for comments. And also, since matrix definition and matrix distribution are the primary work for the next step, are there any reflections or comments on whether current requirements should be improved? So thank you. Any comments?
Daniel, please.
Daniel Huang, ZTE. About the first question, I believe it's quite important and necessary to update our definition of the computing service of the two existing working group documents. Because particularly when the mailing list is, there's a discussion in the mailing list about the SFC, I believe it's much more important to clarify what the computing service under the CAST architecture is. Because from my point of view, SFC actually is the service function is networking service function rather than the computing service function under CAT. So I do not believe the computing aware the functionality of CATS will be taken advantage of in SFC scenarios. So I think we need to clarify the definition of the computing service. Thank you.
Okay, thanks.
Chen Li.
Hello, Charlie from Huawei. So yeah, we received the comment. So I think we should update the service, computing service definition into draft. So we'll do it as soon as possible. Thank you.
Thanks.
Okay, it's good to really show the discussion in the mailing list in the meeting. I think we should get the consensus about the relationship of CAS and SFC. And for the metric distribution, we have 2 and 3 presentations today. So I think the authors could work together to refine the WG documents.
Yeah, and I would say that don't leave it to the document editor to come up with a new definition of computing service. If you've got opinions, please put them on the list.
Yeah, sure. Thank you.
Okay, thank you. Next, the framework.
Hello guys, Charlie from Huawei. Okay, so let's begin. So today's topic is about the framework drafts update. So yes, I hope all of you have known that we have adopted this draft as an working group document. So next, please. So basically, the agenda today is about 2 parts. The first one is about the changes since the last IETF meeting. So we update 3 times, three revisions from 03 to 06. So we will introduce the basic information of the update, and then we were going to introduce the pending issues and what is next step, something like that. Yep. Next. So this page shows the update of the from revision 3 to 4, And in this update, we address 13 issues, and most of them are editorial, right? And the updates mainly include like we update the definition of terms, including like service request and cats forwarder, cats path selector, something like that. And we also delete the description of the CSID does not need to be global unique, though this sentence, but because we don't think it is correct in all cases, right? And we also will rename the service request to be service access. And then we also add some example of service specific packets and related references. Yep. Quite simple. Next, please. And regarding the updates from revision 4 to 5, we fixed some editorial comments from Hang Shi and Kristen and Jack Net. Sorry, I'm not really sure I'm pronouncing your name correctly. And Cheng Li, Zhongpeng, Luis, and others. Yeah, we received a lot of comments from the mailing list. Thank you for your comment. It's really helpful. Yep. And we also clarify the CATS metric can be aggregated. I think that is quite important. Yep. And we also clarify the CC metric may be distributed by different parts in to ingress CATS forwarder. So we didn't specify that we have to do something or we have not to do something. We don't specify that. Yep. And the last point is about the we clarified the CTS and CPS, right? And yes, next. And the update from revision 5 to 6 is a major update of the draft because we merge the content from draft, YARCATS, awareness, architecture, right? So first of all, we have to thank the contribution from the authors of this draft. Thank you so much. Yeah. So we merge a lot of content into this draft. Like we add a new section 3.3, right? As a framework overview to provide a high-level overview of the CATS framework, but it's in an initial version, right? We need to add more text to explain the details of the version of the framework, and we welcome any comments and contribution of this part. And then we add some text, yeah, in CPS definition to explain this logical component can be implemented on a controller. So we avoid to introduce another new terms called something like a central controller, right? Because we describe the framework from another angle, right? And we also add the and then we add 3 deployment models, distributed, centralized, and hybrid in the draft in the deployment section. And we also add some related text and figures to show what is the distributed or centralized or hybrid deployment mode. And as well, we still need more comments and contribution here. So welcome, guys. And then we finally we also had some examples of a service access packet in the service access processing section. Yep. And some other editorial additions. Yep. Yeah, so this is the sample of the CATS deployments. I won't go into the details. Please go to read the draft. We do provide 3 models right now. Yep, comments are welcome. Next. So let's repeat again the current state of the draft. So first of all, we have adopted the draft as a new working group document. So we passed the IPR call with no IPR announcement, and then we receive a lot of support in the working group adoption call. Right. So thank you so much again for the support. Let's work together to move it faster and make the draft better. And yes, We also received some comments that should be addressed in the future as soon as possible in the working group last call from Joe, Happen, Dirk, Chorson, and Hang Shi, Hui Zhen, and others. Yep. Next. Yeah. So we also record the pending issue in GitHub repository. So this is a link. So if you want to add some new issues, so go ahead to add right there. We can discuss and adjust them one by one. Yep. Thank you. Next. Yeah. So the last page is about the next step. We plan to adjust the pending issues step by step. Hopefully, we can adjust one or two after the meeting, and then we do really seek for more reviewers because it is only the 0.1 version right now. We still have a long journey to go. It definitely not the final version, right? So we need a lot of contribution, a lot of discussion, a lot of comments. So welcome. Yep, let's work on it together. Thank you. Comments, questions?
Okay, Daniel, please.
Daniel Huang, ZT. It occurs to me that in the latest version of CAT's architecture, the last stop of the traffic, service traffic would be service contact instance. So I'm wondering where the service instance will be positioned under the CAT's architecture, because this is explicitly defined in the section 2 or section 3. Please correct me if I remember wrongly. So my suggestion is to we need to make clarification about the service instance in the CAT architecture, because actually from my point of view, either the control plane or data plane, we do not have nothing to do with the service instance. We from the control plane and data plane, we only see the service contact instance. Thank you.
Yep. So I don't think I can provide a final answer here. I would suggest you to send an email regarding this question to the mailing list, and let's have more discussion on the list, right? And at this moment, I would say the design of service contact instance is for avoiding to expose too many, details of service instance, so that we can do some like aggregation of the metrics, something like that. So it would make the architecture or the framework more clear, right? So, but anyway, we can have more discussion on the list. Yep. Thank you.
Okay, so we can't decide where the service instance is, but we just to do the traffic steerings based on the location of the service instance at the first. And there are no more comments in the queue. Thanks a lot for the authors do the hard work to merge the draft. And I think there's still some comments during the adoption call.
Yeah.
And so please just revise. And another is that please be aware of other drafts, which might be valuable to enhance the framework document.
Thank you. Yeah, we do. Thank you.
Okay, thank you. Next is about the metrics. Zhongpeng, please.
Hello, can you hear me?
Yes.
Okay. I'm Zhongpeng Du from China Mobile, and this slide is about compute modeling and metrics. And we conclude some talking about the metrics in the mail list. It is for this IETF 119 meeting. Next page, please. Here is some background and motivations. The motivation of computer and network convergence is that some service with a lot of computing resources involved are increasing in our network. And meanwhile, the users of this service expect low latency access. Therefore, the operator need to deploy this cloud plus MEC's service structure. In this structure, multiple points in the network can provide the same service, so that the provider need a proper scheduling method for this for those user requests, so as to load balance both the network resource and the computing resource. However, count anycast mechanism will only consider the network distance without computing information, and the count load balance mechanism will mainly happen in the DC, and a user request may be redirected to other places. We are shuttle on path load balance mechanism based on our network, and the image, the traffic engineering will be near to the users, and it with the knowledge of the computing information. Since the decision point in the network should be aware certain degree of computing information. Next page, please. This page we conclude get some conclude about the usage of computing metrics. In the mail list of CAS, it is talk about that computing model and metrics can refer to the work in DC management plan. For example, the redfish and the Untitled project. However, it is mainly about computing resource management, which can be used for example, service deployment. Is to say to find a place with enough computing resource to establish a service or service judgment. And potentially a uniform metric for bidding would be also be make sense if we want to make the service of heterogeneous computing resource treatable. However, in CATS group, we mainly care about the computing metric that need to be announced into the network, which will influence the route for the service ID. Normally, the service ID is an anycast IP address. Even we see that the CAS metrics can even be a subset of the metric used for the management plan. Next page, please. And in this page, we introduce some metrics examples. For example, from the redfish, we can see that redfish is a standard designed for deliver simple and secure management for this DC, and it is human readable and machine capable. We can see the finger on the left. It has some metric about computer system. For example, the processor, the disk, and the NIC. And in the right, we show some general metric for the management of a server. For example, we can see the status about the drive, CPU, memory, and others. Next page, please. And this is another example mentioned before, the Anukit. They drive a common model, a standardized reference infrastructure specifications for many the virtualized and the cloud native network function. We also have some finger about it. We can see the left finger is about virtual resources. It include compute, storage, network, and about compute resource. We can see some list. The vCPU, the RAM disk, the NICs. Next, please. Next page, please. In this slide, we give some analysis about the requirements. As mentioned before, we would mainly care about the CAS traffic steering. For example, the decision point of the CAS is ingress. The main job would be for the ingress is to select a proper egress, which connects to a proper service side. And for us to select an egress, the ingress would not need all the computing information on the management plan. We have an intermediate meeting before, and some suggestion was get. The first one is that the computing metric in CAT should be few and simple, so as to avoid exploring too much information on the service point. The second is about the computing metric in CAS should be evolvable for future extensions. And the third is the update frequency of computing metrics need to be considered carefully, so to avoid too much pressure on the network node on the control plan. Generally speaking, we have the conclusion that we should start with the simple cases. Next page, please. To start with simple cases, we have a lot of talk from the mailings. We have 3 potential metrics that are considered as the start point. The metrics is considered too worthy to be announced into the ingress and influence the selection of the egress and or the service side. The first one is the predicted computing delay. About a minute is the estimated or duration of my process of the request. It is a metric that can be parsed with the network delay, so it's easy to use for if we want to get the minimum total delay for the service success. And the second one is the service capability. For example, one server can support 100 simulated sessions, and another can support 10,000. So that we will prefer the second one because it has a much better service capability. The third one is the status indication. For example, an indication of please stop sending new sessions to instance A. Other metric can also be considered in future if it is considered to be valuable. Next page, please. We also find some corresponding metrics and the optimization objective. Which metrics to announce is relevant to the policy in the decision point, for the example, for in the ingress, and the policy in the decision point is relevant to the optimization objective of CAS. We have 2 main optimization objective in CAS now. The first one is to minimize the total delay in the network domain and the computing delay domain. We just add the predicted computing delay and the computer and the network delay. So we can get the minimum total delay to optimize the user experience. The second one is to load balance. Load balance both the network and the computing resources. The service capability metric is very valuable for this purpose because we can see that it can be work as a weight value for load balance. The operator will care about the second optimization object more because service capability is relatively static. The third metric, status indication, would be helpful when the server is a heavy load. However, it's a temp and dynamic value, so it can only work additionally. As a conclusion, we can choose a default optimization objective. Currently, we have 2 candidates for the services in CAS and have 1 or 2 related default metric for it and make things happen firstly. I think it's all. Thank you all and welcome for comments. Thank you.
Okay, sure. No one in the queue, so we may move to next presentation, and maybe there will be some discussion together.
Hello everyone, this is Luis. So I will be the one presenting the, the draft instead of Jordi. So, and I will do it on behalf of my co-authors, so Sabine and Roland as well. So yeah, continuing with the topic about the metrics. So the motivation, I think, more or less also was covered by Songpeng. So essentially, we are in a situation where somehow the metrics related to the network information are more or less stable, and there is a lot of work already being done and being done here in IETF. However, from the computing perspective, there is something work to be done in that respect. So there is the need of defining these metrics in order to support new use cases. We have the cult use cases. Some other use cases also could require of this need of having the metrics, of consuming the metrics. We will comment later on in the next slide, but just to anticipate that. There is some ad hoc work already existing in IETF, for sure, the work in CATS, that's clear. We have just seen the presentation from Songpeng. With let's see, the perspective of the angle of serving the traffic steering purpose. Then there is another previous work as well in Alto Working Group, more oriented to the fact of exposing the compute metric information. And then some other previous work even in OPSO with the specification of a MIP for the management of the virtual machines, so somehow also related to compute in the sense of there is some specification of resources there. Apart from the work done in IETF, there is some other external work done in other venues. Also, Songpeng mentioned that. But here, just a quick reference for Linux Foundation, the MTF, sorry, ETSI, NFB, and so on and so forth. All this work covered also the different angles, or span through different angles. The raw compute infrastructure metrics associated to the virtual network functions, to the service functions, finally, and other metrics that somehow combine or relate compute and network information. That could be the one about the network delay, service delay, and so. And finally, scalability as well of the service functions, so the number of sessions, these kind of things. Next, please. So the problem space that we try to cover in the draft, we depart from the idea of satisfying the service life cycle. Here we have just listed the service deployment and the service selection. Probably we could consider it as part of the service life cycle some other stages like the service assurance, the service optimization, and so. But in trying to not overcomplicate the things, we by now are looking at the service deployment and the service selection. What we can see from once we go through the service life cycle is that there will be different actions to be taken, different information to be consumed, and also different actors as well to participate of that consumption. So we have, for instance, for the service deployment, we need to take an action of service placement. So we need to understand where the compute resources are, and also what are the network information, the network metrics, let's say, associated to those compute resources in such a way that we can derive from that metrics useful for understanding what will be the impacts of instantiating the function here or there. On the other hand, for the service selection, we could have the different actions like the selection of the service instance itself or the selection of the path to reach that service instance. So again, we could here take into account compute and network information, and we could also see different actors to consume that metrics. So the problem space also was evident from the presentation from Songpeng in somehow broad. Next, please. So regarding this particular draft, we already presented the version 01 in the previous IETF meeting. From now on, we have produced an update. Now we are now in 03 version. What we have done new, what we have added new in this draft is a number of use cases in order to motivate and justify the need for the different kind of compute metrics. So somehow trying to illustrate the problem space as well I was referring before, concentrating in deployment and steering by now and service selection by now. We have added a new section on the production and consumption scenarios of these compute-related metrics. So in such a way to understand what could be these actors, what would be the ones requiring the compute information, but also producing the compute information. We are providing references to raw resources, to allocated resources. So there are different needs, let's say, or the metrics apply to different aspects, right? Also, we have added a new section on metric selection and exposure. There we, on one hand, we provide a reference to how the metrics could be exposed and which kind of metrics needs to be exposed. Again, this will be related to the kind of part of the service life cycle that we want to address. Also, we added some discussion on the dimensions to consider when identifying the compute metrics, what kind of angles to look at the metrics, discussion about the abstraction required according to who consumes the metric. So probably we need to deal with different level of abstraction. So this goes in the direction of the simplicity that was commented on PEM before. So trying to scope the metric to who will consume the metric, right? And also reference to the distribution and exposure mechanisms. And finally, we added Roland as well as co-author. Next, please. So the next steps, we would like to collect feedback from CATs. There are already some discussions in the mailing list. We would like to have even more discussion. We understand that there are, let's say, common points for sure in which is our ambition with what will be chartered nowadays in CAT. So we understand that we need to do some work together on that for sure. And our idea would be to prepare a new version for next IETF, and for that version to incorporate the comments that we can receive today from CATS, and also the presentation that Jordi performed in NMRG before today, and also the same meeting on information exposure for edge computing. So the idea is to try to, let's say, define better the problem, understand what is needed, and with that, keep progressing and working together with CATS on the part that could be applicable to CATS. That's all from my side. Thank you.
Okay, Daniel, please.
Okay, Daniel Huang. We're actually, when we're talking about service to computing metrics, what I am keeping in my mind is that we have to make the joint routing decision in terms of both service and networking metrics. So as an engineer, I will do my best to make the metrics, network, particularly the computing and service metrics, as compatible as we could with the existing network metrics. So we have to be careful when we're talking about employing a complex service metrics structure into the CAS architecture. So I would second the thinking from Zhongpeng's presentation. We have to make the computing metrics as simple as possible. Thank you.
Yeah. Thanks, Daniel. Just to comment on in the draft, we explicitly say this, that the purpose is not to reinvent the wheel. For sure, reuse as much as is already there. That's clear. And the tricky point here is regarding the simple metrics that we need. For instance, in the presentation before from Zhongpeng, he was referring to the server load. But the server is something associated to the service function, or is something associated to the resource. So I think that we don't have yet a clear view what is associated to the steering purpose. So this is why somehow what we are claiming is to take a look to all the service life cycle, understand what could be the kind of metrics that we can consume to that, and from that point on, then identify what could be useful for the traffic steering purpose, and maybe for other purposes of the service life cycle, probably we can use other metrics. But somehow the idea is that not to see what is out there, and from that start identifying what could be applicable to one part of the service life cycle or to other parts of the service life cycle. This is more or less the idea.
Chun-Li from Huawei. So first of all, thank you for the work. I'm really happy to see that, and I will try to participate more in the discussion. And then the second part is, I do really believe for the metric from computing to the network should be done in the CADs. But regarding the metric from the network to the computing side, I'm not really sure where should we go to do that yet.
Yeah,
thank you.
Thanks, Henry. Yeah, we agree that there is for sure work to be done in CATS, and there is a common ground. Or the point is that the charter from CATS is so specific that somehow our concern is that we could lose some other metrics, as I was referring to the server load, for instance. So our approach will be to go to the metrics, to understand all the metrics, and for that probably narrow down the scope, rather than starting from a small scope and then trying to make it wider.
Yeah, we can discuss on the list. Thank you.
Thank you.
Dong Yuan from the DT Corporation. Thanks for your presentation. I got two brief comments. The first one is about the service deployment and service selection, two phases.
At this point, I want to add some maybe universal contents that with some serverless mode, we know that the service deployment and the service selection phase may be getting to just one phase. That when we look for an idle instance or idle resources, we can just steer traffic to there and they will invoke a new instance or get a request to handle this kind of service request. And for second comment is about the joint exposure of network and computer matrix. It's my considerations that some of the matrix in the computing side may have the same dimensions as the network side, and this kind of be calculated or considered to be an accumulative form. But some of the computing side matrix should be evaluated individually. And I think that it is important. Maybe we should just classify this kind of matrix and to make it just simple concluded as some types, so we can handle it to be more simpler.
Thank you for your comment. Going to the second comment first. Yeah, you are totally right. There will be some of them that could be composable, some of them not. So yeah, we need also in this process of metrics to understand what could be, let's say, the base metrics. And for that, what could be the ones that we can derive, maybe composing them, maybe doing some other processing, I don't know, some statistical processing for extracting quantiles or whatever. But it's true that there will be a kind of basic metrics. And for that, we can elaborate some others on top of that. Yeah.
Yeah, thank you.
And regarding the first comment that you did, I didn't get very well. I think that you were referring to the fact that probably the two stages in the service lifecycle could be done at the same time, yeah. But certainly even done at the same time somehow are different processes. You need different things to go through them. So even though can be executed together, let's say, even in that case, you have different needs, let's say, in each of the stages. I think this is my view.
Yeah, I got your point.
Thank you.
Adrian, please.
So I'm really happy to see these two drafts getting some discussion and progressing, because it's been a big hole in the CAT's work. I think ideally we would have generic compute metrics that can be used by CATs and in other places. But I don't want CATs to get bogged down discussing compute metrics that are not appropriate for CATs. So we have to be a bit delicate and careful about how we do this, so that we don't have CATs waiting for super generic or other specialist use cases. I think we still lack understanding of what metrics can actually be exposed by the servers. And we also don't clearly understand what the steering function really needs to know in order to successfully steer. So we've got a long way to go. And as chair, I'm wondering how we should best handle this. And I think this is going to have to go to the list, but we could have an interim dedicated to discussing metrics. We could have a design team to go away and maybe meet weekly discussing them. Or we could just do the work on the mailing list. So not asking for opinions now, but start to think about this, and we'll try to make a decision on the mailing list quite quickly. Because I think that if we just roll along saying, we'll update the drafts and come back at IETF 120 and so on, that's going to be slower than we should be.
Thank you.
Yeah, thank you.
Next, Jeff, please.
Jeff Tensur, a couple of questions. One with regards to path selection, path computation. Do you envision dynamicity where next element in the path would be dictated by the previous one rather than fully computed path like we do in PC, for example?
My short answer would be no. I need to think on that.
Next
okay, I'm
question.
going to butt in here, Jeff, because you're talking about the path, and we don't do paths. We do steering onto paths.
Sure, I understand, but what if the path resolution is dynamic and based on previous computation?
Okay, yeah, I get your point.
Question number 2, and I think someone mentioned inference, collective operations. So they're not only based on resources available, but on proximity among each element computing, right? So they need to be pretty much equidistant. Otherwise, you'll be on the kind of slowest link, because collective operation requires everybody to do the same thing at the same time. Do you envision including proximity as a metric?
Could be one of the metrics, maybe could be represented in terms of delay or latency, which is something that is, I think, fits on the framework, because we will have this network metric agent. So probably affinity. Okay, I got it now. You mean between different instances of the service, right? Yeah. Yeah, probably could be one of the metrics to be considered, but we need to realize how this could be reflected, maybe through the latency between
Exactly. It could be array of latencies among the participants.
Yeah.
And then question to Adrian, are collective operations in scope of this working group? I mean, there are some INC or in-network compute work progressing all across IETF. What part of it should be here? What part of it should be someplace else?
Well, the part that should be here is the part that's in the charter, but I'm perfectly happy for us to import that if it's done elsewhere, or to learn from what's done elsewhere, or to discover that we're entirely different. Can you do something for me? Can you send pointers to either to the chairs or to the list to the work that you think is happening elsewhere that we should be aware of?
Yes, so as the chair of routing working group, there are 2 drafts progressing in routing working group that are related to in-network computing. I assume authors are here. I don't see them, but
okay, we will dig into that.
I'll send it to the list.
Yeah, thank you.
Thank you.
Okay. Thank you for the discussion. We may find some way to really enhance this work. And next.
It's me as well.
Yes, I know.
So hi again, this is Luis from Telefonica. I will present this other draft about the how to leverage on CATs for bit hole networks. I will do on behalf of my co-author Mark. Next, please. So the departing point, the departing idea is motivated by the trend in the radio part about the disaggregation, right? So the initial sorry, the initial deployments of in the radio networks were to have all the processing capabilities in the antennas. Okay. So basically forming the backhaul segment between the antennas, the aggregation part of the radio, and the packet core, the process doing the final processing of the radio signal. So the antenna is collecting the analog radio signal, processing it, and then sending to the, generating the packets, the IP packets, and so generating to the backhaul. This was the starting point. With the disaggregation in the radio, the fact is the idea here is to take all the processing stack of the radio and distribute that in different elements in the network. So in such a way that we can have essentially the processing of the sampling of the analog radio signal getting the antenna, then the real-time processing of that signal in one element called DU, which is distributed unit in some place in the network. So generating the front haul segment between the antenna and the DU, and then moving the rest of the processing capabilities, mostly for non-real-time aspects, into another entity called CU that could be even further centralized in the network. So between the DU and the CU having the mid-haul segment, and then from the CU to the packet core, and so having again the backhaul. So this is the starting point. So next, please. So the motivation then, how to or why to take this for CATs is that basically, as you can see on your left, the way of realizing this from the point of view of connectivity in a network would be typically having the RU, the DU, and the CU connected in the network, right? being attached to, which is called in ORAN terminology TNE. That would be transport network element, but could be is homologated to the PE in IETF, let's say, vocabulary. So taking the picture from the left and moving what could be a representation on the right applicable to CADs, we could have the DU units and the CU units running as virtualized entities. Then for the, I represented the DU on top of a server, but could be also a data center, and the CUs running as virtualized functions on different data centers. So the segment between the DU and the CU is the mid-haul segment, as you can see on the figure. And essentially, we would have a number of compute elements, servers or data centers, interconnected through a network. So different PE nodes and so on. We could have different instances of the CUs. We could have different, like in data center 3, different instances of the CU on the same data center, or different instances in different data centers. So the point here is how, to what extent we could use CADs to solve this connectivity scenario. Next, please. So when thinking on how to apply the CADs framework to the mid-haul segment, the idea would be to consider the DU as a client of the CU instances. So essentially playing the role of client in the CADs framework. Also considering that with the CADs path selector, we can take the decision on which CU deliver the traffic of each DU. So basically taking the decision according to the network metrics and the compute metrics observed in the deployment of the different CU instances. So the network monitoring agent and the service instances monitoring agent could do the job of exporting the metrics of the different environments, the network and compute, and then helping the decision from the CADs path selector. We have simplified, we have added or we have considered as an example of this in terms of data plane, the network slicing. So we are assuming that we are using network slicing between DU and CU, and this is somehow, this simplifies, I mean, this is a way of not entering into the details what could be the data plane, because somehow you know that the network slicing approach in IETF is technology agnostic. So we are doing the example with network slicing, but could be any other data plane underneath. Next, please. So the next steps for this will be to cover a number of open points that we already have identified in the draft. For instance, the fact that in the CADs framework, we assume that there will be some identification of particular flows for delivering to the service functions. Here, in the case of the DU, will be all the flows, so not a particular flow. So we need to understand how fits this with the CADs framework and some other aspects that are detailed in the draft. We would like to collect feedback from the working group, to understand if this scenario is I mean, of relevance for CADs. Prepare a new version and also come back to the ORAN Alliance with this idea of leveraging CADs for solving this connectivity. And that's all from our side. Thank you.
Okay, thank you. Tianji.
Louis, thank you for the work. I'm seeing one bug. Here's the case that you are trying to have the DU to select one of the CU part. But on that, the radio accessing, the DU has not opened the IP yet. How are you going to know your IP part?
Yeah, we need to think on those details for sure. There will be an interaction. Now, taking this to the ORAN staff, we need to think what will be the interaction between the SMO and the transport management entity in ORAN for sharing the information and doing such kind of decision. So this is something we need to work on. Say.
But your PTCP IP stack is on the client, on the UE side, on the CU side. But in the middle, I don't know how you're going to get that IP level. Here we're talking about the CADs, right?
Yes. So, well, okay, I think I got you now. So the point is that in mid-haul we have IP connectivity. You don't have, I mean, you are tunneling all that pre-processed signal on top of tunnels, IP tunnels. So you are basically delivering that between the CU and the U. It's like any other traffic. It's not an IP traffic because you have not completed the processing of the signal, but you can deliver that traffic using IP networks. So the payload would not be IP, would be a pre-process or an incomplete process radio signal.
Okay, we can talk about offline here because I'm really confused with how you're going to do the NAS and AS message here. Yeah,
Okay.
we can talk about
Okay.
offline part.
Okay, thank you.
Okay, thank you. Please continue to discuss this work.
Thank you.
Mailing list. And the next. Please.
Hello everyone, this is Han Shi from Huawei. I'm going to discuss about how to distribute the metric. There is some design choice involved here. Next slide, please. Yeah, first a quick recap of the CAS framework. There are two concepts. The first is the SMA, service metric agent to collect the computing metric. The second is the path selector. And the SMA need to distribute the computing metric to the path selector. And so there's some design choice around how to collect and how to distribute this information. Next slide, please. Previously in this draft, I discussed several approach regarding different kind of deployments. You can use a centralized or distributed CPS or CSS SMA. So this gives us 2x2 matrix, each have its own pros and cons. It's in the draft, you can check that out. Next page, please. Yeah, but regarding how you deploy these components, we still have other problems need to address regarding the metric distribution. We need to analyze the metric distribution overhead. Actually, we can have some kind of very simple formula to compute the metric distribution overhead. There are two sides of this metric distribution. The first is a producer.
Sorry, please step back a little. On the mic. Yeah.
Okay.
It's too loud.
Okay. Yeah. The first is the producer of the metric, and it's pass the metric to the consumer. So these two sides. The first component of this metric distribution is the scope. Not every consumer needs this kind of information, and not every producer can produce some meaningful update. So there is the second part, the metric distribution frequency. If a consumer does not need it, we may not distribute the metric to them. And the third one is the metric size. Metric size is determined by the metric model. What kind of computing metric is involved here? Next slide, please. Yeah, the first optimization you can do is to reduce the scope of metric distribution. Basically, you do not need an all-to-all distribution of the computing metric. And there is a draft in the IDR proposal concept about the notification domain. Basically, it's kind of group the ingress and egress. So they are only get their meaningful update to them. And to achieve this notification domain, actually there are several proposals to how to implement it. The first one is use some kind of pop-up mechanism. The idea is that the consumer indicates the interest of this computing metric of a specific service by sending a sub-message, and after that it can get some kind of update of this computing metric. And the second one is kind of split the egress into different groups. If ingress and egress is too far away, it's highly unlikely that egress will be selected. So we don't need to pass this computing metric between them. Next slide, please. And the second part is inside this computing metric distributes the scope, we still need to determine how frequent we distribute the metric. How frequent we need to do. There are two modes of this metric distribution. We call it push or pull. Basically, the push is producer send the metric to the consumer, and the pull is the consumer fetch the metric from the from the producer. And and we can do similar optimization to limit the distribution frequency. For example, in the push mode, we may need to set a threshold for the metric update. If a metric does not change that much, we don't need to update. And for the pull side, we can use some kind of cache mechanism. Only fetch when the cache expired. But you can see here, each side has their own view. The poor side, the consumer of this metric is Ingress, so it has the information about the client join and when the client need a new metric. And the push side, they have the the computing metric update. So they some kind of need to align together. Next slide, please. And this draft is kind of intended to summarize the related work regarding the metric distribution and to inform the discussion about this. And ultimately, it was intended for the protocol design. So comments, suggestions are welcome.
Daniel, please.
Okay, Daniel Huang. I have two questions. The number one is why the consumer will be taken into consideration when we're talking about the service the metric distribution overhead, because in my view, the metric would only be propagated and distributed within the CAS architecture, which would not include the consumer side.
No, this consumer is the CPS, so it's in the
okay.
not than the user.
Okay, good. The second comments is about the service metric agent, because I would assume that cats will get the computing original information exposed by the computing side as the on, rather than we would not assume that the computing side would make some kind of refinement and calculation for cats. So it would be the job of cats forward or the service metric agent to make the kind of calculation and the refinement according to the CAS architecture. So I would agree with Adrian's suggestions to the working group set up the design team to clarify about the service metrics, particularly the principle of the general service as well as the computing metric and the relationship between the service metric agent and the computing side and the CAS forwarders. Thank you.
Yes, what you are talking about is a metric model, and it's between the CSMA and the computing side. What I'm talking about is between CPS and CSMA. It's inside the CAS forwarding area.
Yeah, now what I'm talking about is I would assume the computing side will not do anything with regard to the original computing information. It would simply expose what they have. So it's the job of CATs, either the CATs forward, egress port load, or the service metric agent to do the job.
So you are assuming server side does not do any aggregation or pre-processing of the CAS of the computing metric, and it's done by the, for example, this CSLMA.
Yeah, I personally I would not assume that because it's going to be the two different administrative domains.
Yeah, and I think that's what the metric model will care about, what kind of information and how to get this information. Is kind of pre-processed in the computing side, or you get the raw data?
Yeah, it's about two things. I think you care about if the server can tell something for cats, or cats just to get some computing information from the server, or the server can change and do more things to fit CAS requirement. And this draft talk about how to distribute the informations when the CSMA gets the information, I think. So it's also about the Adrian's point about the metrics draft, that what CAS can get from about the computing metrics. Yeah.
Yeah,
So Adrian,
we've got a sort of feedback loop that we need between this draft and the metrics draft, because this formula is spot on. It's good, but what we now need to know is some of the details of, well, for example, what is the metric size, and then we can put that back into this draft to say, because our metric size is this, it rules out some options and rules in some other options.
Yes, agree.
Yeah, okay.
okay, thank you. Okay, next we will have 4 quick presentations. Okay, Chen, please.
Hello, Chen from Hoyo again. So this is a quick introduction of our drafts, which is about using segment routing SR as the data plane of CAT. So next, please. Yeah, so in the draft, basically we describe how to use SR, including SR impures and SRv6 as the tunnel encapsulation for from the ingress CAS forwarder to the egress CAS forwarder. But actually, you can use other mechanisms. We don't really care about that. In this draft, we specify a potential implementation of CATs. Like we define that we can use an anycast IPv4 or IPv6 address as the CAT service ID, which is the CSID, right? And for the CAT instant selector ID, CISID, it can be a Ampere's label or SRv6 seed, such as NX seed, and pointing to the service instance selector. And for the CAT component, we require them to support Ampere's or SRv6. And we also describe how to realize the CAT workflow by using the DNS technologies and SR as the data plane encapsulation. Regarding the metric distribution part, we think this is out of the scope of this draft, and that should be described in IDR or other working group drafts. Other drafts in IDR or PC or other working group. Yep. And yes, that's it. Thank you. Please read the draft.
Okay, next, Han.
Yeah, this draft is about a particular problem or particular deployment, because sometimes you may need to deploy multiple service context instance or several sites behind one CAS egress, and then you need to distinguish between those sites, how to route to the right side. And if they are connected to the different interface of the CAS router, CAS egress, then you can use some kind of interface ID in SRv6 and point DX seed. And if they are connected to the same interface, like in this figure is shown in router 1, and then you need another kind of locator to locate the right site. We call it a real locator, and there are 2 options to encapsulate the real locator. The first we call it the tunnel mode. Basically, you give a tunnel from the egress router to the site, and the tunnel outside tunnel IP is the real locator, and the inner destination IP is the service IP. And the second is forwarding mode. Basically, you can encapsulate the real locator in the IPv6 extension header, and between the CAS router and the edge site, you need to read this IPv6 extension header to get the real locator to do the forwarding. Next. Okay. Yeah, next we call it the application-aware computing network. Basically, this is one way of implementing the CAS framework because we see many similarity between the concept of the CAS framework and this APN. There are several important IDs in the CAS framework, the service ID and SCI, service context instance ID, and the flow ID. We see in the APN ID, we already have application group ID and the user group ID. We can use the application ID as the service ID and use the user group ID plus the application group ID to replace the file tuple as the flow ID. So it's kind of directly match. And to encapsulate this APN ID into the CAS framework, we actually have two options. The first option, if you can put the APN ID inside the address, so we can call we call it the APN segment. Basically, it's SRv6 seed, and the function part is the APN ID. And the second, if the APN ID is too long, we just use the locator and put the APN ID in the IPv6 extension header. So this is one way of implementing the CAS framework. Yeah.
Okay, thank you. Next, the last one is Carlos, please.
Hello, I hope you can hear me well. So this is a solution draft proposal by myself and Alain Morin. Basically, here I'm covering two slides, or two drafts. One is the main kind of solution overview of how to use IP address anchoring for CATs. And then another one, the companion document that is about how to do service mobility in a CATS environment, also using IP address anchoring. Next slide, please. So here you can see a figure trying to summarize the overall idea. The terminology has to be a bit updated according to the last developments from the working group documents. But the idea is that here we use IP address anchoring to support CATs by basically making the CATs forwarder that is connected to the service side allocate an IP address block or an IP address to the CATs forwarder that is connected to the or close to the terminal. And then by using this IP address anchoring, we support the CATs forwarding, and we can do updates on the CATs forwarding by kind of using IP mobility mechanisms, so extending IP mobility signaling. So for example, if we have mobility of a given, or we want to have mobility of a given service instance or mobility even of the terminal, we can do that by following mobile IPv6 kind of signaling for CATs. And that's the overall idea in summary. So of course, we would like to welcome any comments that you may have and send those to the mailing list, and we welcome any potential interested contributor to join us on these efforts. Thanks.
Oh, Adrian, do you want to say something?
Yeah, I just wanted to say it's obviously a little bit early for us to be working on solutions. But the reason we did these flash talks was to just show that there's work going on and to bring it to everybody's attention. I'm slightly amused that we're all focused on how do we get the packets across the network and identify the compute service that's needed, but we're still some way off being able to actually make the steering decision, which is an equally important piece. I think because we've got a little time, I want to do 2 process polls, show of hands. The first one is, do you like having these flash presentations? Is this a useful thing to do, or should people just read the mailing list and get on with it? So if you can find that and vote, that would be really interesting.
So we are starting the show hands. Please join in the mid icon.
Okay, that seems to sort of be stabilized. Still voting. Okay, it looks like this is something that you think is useful, and the chairs can look at future meetings if the agenda space allows. Okay, I'll stop that. And my second question is about how we progress the metric discussion. And the question is, would you like to be driven on this discussion by the chairs scheduling some form of meeting? I suppose the no means no, we just want to work on the mailing list.
Okay, now is the second question. Please check in the show hands.
Okay, thank you. That's pretty helpful to me as a chair. Pong and I will talk about this and try to work out how to drive the metric discussion forward. Okay, back to you as resident chair.
Yes, we still have 8 minutes, and maybe anyone has some questions for the WG or for the draft presented today can join the queue. Okay, if no more questions, maybe we can close our meeting. Adrian, do you want to say more things?
No, that's good. Thank you for taking the pain of traveling this time. And maybe you'll see us both in Vancouver. Who knows?
Okay, thank you, everyone. We are closing our meeting. See you in Bangkok.